Welcome to the Labflow workshop. Today we will investigate the 10th experiment in Labflow for CHEM 1412, which is determination of the amount of sodium hypochlorite in bleach. The objective of this experiment is to perform a redox titration to determine the amount of sodium hypochlorite in commercial bleach. The active ingredient in bleach is sodium hypochlorite. Here, sodium hypochlorite. This is the active ingredient in bleach. You have already done in this course many titrations. So the only difference between a redox titration and an acid-base titration is that in redox titrations, there is a redox reaction between the titrant and the analyte instead of an acid-base neutralization reaction. So we will actually perform two redox titrations in this experiment. One titration is to determine the concentration of our titrant, which is thiosulfate. S2. This is our titrant. And that is called standardization. This is the first thing you are going to do. And the second redox titration is to determine the amount of hypochlorite in bleach. So for the titration, assuming we already know the concentration of thiosulfate, we already standardize our titrant. So for the titration, to determine the amount of hypochlorite, we use thiosulfate as our titrant and add thiosulfate to our sample that when you read the procedure, we will do that. Our sample, we will have a flask here, and we will have the burette. This doesn't look good. We will have a burette filled with our titrant that we know the concentration, and we are going to drop our titrant, and our analyte here is 25 ml of bleach plus excess of potassium iodide plus sulfuric acid. This is what we are going to prepare here. We are going to add our titrant here until the end point. So let's see, we need to understand what reactions are happening. Otherwise, even though you are not doing the reaction in the lab, you still need to understand all the steps in order to do the calculations in the report and to do the pre-lab quiz. So we first react the bleach with excess of potassium iodide. Let's look at this reaction. This is the active ingredient in the bleach, hypochlorite, and we make a reaction with excess of potassium iodide here. And according to this equation, the amount of hypochlorite which we are interested in is calculated by titrating with thiosulfate the amount of iodine produced. If you look at this reaction, the number of moles of elemental iodine equals the number of moles of hypochlorite. So if we titrate and we calculate the number of moles of elemental iodine, we know the number of moles of sodium hypochlorite. So basically, the reaction, we add excess of potassium iodide to convert all the hypochlorite to elemental iodine, and then we titrate the iodine with sodium thiosulfate. So the reaction of the titrant thiosulfate with elemental iodine is this one. This is the reaction. So as we add our titrant, the thiosulfate, the iodine is removed from the solution according to this reaction. So the end point is found by adding starch to the solution because the starch forms a dark blue color with elemental iodine. So the end point is when the blue color of iodine starch complex disappears. We stop then the addition from the burette and record the volume used. And then we will do the calculations. We will go over that when we look at the report. So this is essentially how are we calculating, how are we doing this experiment of calculating the amount of hypochlorite in bleach. So we said we had an excess of potassium iodide, convert all the hypochlorite to elemental iodine, and then we titrate the iodine with sodium thiosulfate. What is the other reaction? The other, we said we are doing two redox reactions. The other redox reaction we are performing in this experiment is the standardization of sodium thiosulfate. What is standardization? You know that in all titrations, we need to know the exact concentration of the titrant, the solution that is in the burette, and the volume that we use in the titration until the end point. So we need to standardize the sodium thiosulfate using a redox reaction with potassium iodide. So when you see that in a quiz or in a pre-lab quiz or anywhere that they are talking about iodate, you know that this is the first titration that you are doing. You are using iodate to calculate the concentration of your titrant. And again, what happens? Again, we add an excess of potassium iodine to produce that at the beginning without the starch, you will see a yellow-brown color. And then when you add the starch, it will be a dark blue. So you titrate with sodium thiosulfate until the color suddenly disappears. So it's very similar to the other one. But in reality, here is the equation that you are going to use to calculate the concentration of your titrant. But in reality, what happens is that you have iodate, and you are going to react the iodate with excess of potassium iodide. And you are converting the iodide in elemental iodine. And then it's easy because of the starch to titrate iodine. You will do the titration of elemental iodine with our titrant until the color disappears. You do not have to worry about these two reactions, because if I multiply this by 3 and I add these two reactions, I end up with the reaction that I mark here. This is the reaction. You will need the molar ratio of this reaction. Why I show you these two is because I want you to know that you are adding an excess of potassium iodide, and then you titrate the elemental iodine that forms that blue dark color with starch until you are going to add drop by drop from the burette your titrant until the color disappears. For some students, if I do not explain this part, they don't understand why this reaction is written that way. Let's see what else is in here. I want you to consider additional, before we go into the report and the calculations, I want you to be able to answer these questions, simple questions. What is a titration? You have seen many titrations. This is a redox titration. So you will have a flask with the unknown, and the unknown is your analyte. You please look at all the videos that Labflow is showing, because they will ask you. So basically, you have a stopcock that this is something you can open and close your burette, and your burette is filled with your titrant. Very good. So what is a titration? It is a quantitative technique of slowly adding one solution of known concentration, which is the one is in the burette right here, our titrant, using this piece of glassware called burette, and we add slowly this known solution to another solution of unknown concentration. our analyte. So here is the bleach, or here is what we don't know the concentration, and we need to find out. And then we use the stoichiometry of the reaction between the two solutions to calculate the concentration of the analyte, which is our unknown solution. This is basics. You need to understand this, otherwise you won't be able to complete this report. Let's do a second simple question. What is conditioning of the burette? Even though, as I said before, you are not doing, you need to learn all the procedures. So the question is, what is conditioning of the burette, and why do we need to always condition the burette before doing a titration? First of all, conditioning the burette is rinsing the inside of the burette with the titrant. So first we wash the burette. So that means there is water inside the burette. And then we rinse it with our titrant to eliminate the water or other solutions that might dilute or contaminate our titrant. Because when we do a titration, we need to know the exact volume of the titrant when we reach the end point. So if the burette has water, it's going to give us error. Another simple question. Think that you are in the lab. Are you familiar with all the glassware you need for the titration? As I said 100 times, it is important, even though you are doing the experiment virtual, to understand how to manipulate the burette from the beginning, when you are conditioning, when you are washing it, at the beginning of the titration, or closer to the end point. So watch all the videos and take notes. For example, when you are adding a titrant, so basically you have your analyte, and this is blue. You have the color, the dark blue color of the starch, and you are adding your titrant. When you are close to the end point, what are you going to do? How are you going to manipulate your burette? You don't want to add the titrant too fast, because you might pass the end point. And then when you are going to read the volume, it's going to be higher than the real volume of the end point. So you need to, when you are close to the end point, you need to go slowly. And how do we go slowly? This stopcock, you just move it and you leave it partially open, but it's a diagonal position. And then the flow of your titrant is going to be much slower. You can have it completely open at the beginning when you have to add a lot, but closer to the end point, you need to do it slowly. Now that we went through a little bit of general information, let's go over some questions that are at the end of some practice. It says pre-lab exercises. So I want to make sure there are many problems that are similar to this one in the pre-lab quiz. So I would like you to practice and make sure it's clear. So here it says, pre-lab exercise. Following the instructions in your lab manual, you have titrated 25 ml of sample of 0.0100 molar potassium iodate with a solution of sodium thiosulfate of unknown concentration. And the endpoint was observed to occur at this volume. So first of all, you are going to ask yourself, what redox titration is this one? Is the standardization or is the actual titration to find out the amount of hypochlorite in the bleach? Because you know that the standardization uses potassium iodide, you know that this is the standardization, even though they are not telling you. It's very common to do the standardization of the titrant using potassium iodide. So every time you have a question and you have a titration, you are nothing without the chemical equation. You need to have and write the chemical equation. When you look at your write-up, this is the chemical equation. 1 mole of iodide reacts, it's given in the procedure, with 6 moles of thiosulfate to an acid to produce iodide plus 3 moles of S4O6 2 minus. So you know that this is the reaction that you are going to use to make the calculation of the standardization. Now that you have this, it says how many moles of potassium iodide were titrated. How do we calculate the number of moles? Okay, you learn in Chem 1 that the number of moles of potassium iodide equals, it's always the molarity of the potassium iodide multiplied by the volume of potassium iodide, as long as the volume is in liters. Do we have that information? What is the molarity? Here, it's here. 0.0100. And it says molar. What is molar? Moles per liter. And we multiply by what? By the volume in liters. What is the volume? Let's read it again. We have titrated 25 mLs. When we convert the 25 mLs into liters, is 0.025 liters. Liters and liters cancel, and the number of moles equals 0.01 multiplied by 0.025. So my answer for how many moles equals 0.00025 moles of potassium iodide. Very good. So to make it simple, we calculate the number of moles by multiplying molarity by the volume in liters of this solution. Very good. The second question, how many moles of thiosulfate did this require? How do we do that? Now we definitely need the molar ratio of this reaction. What is the molar ratio? I have the moles of potassium iodide, and I want to know the moles of potassium or thiosulfate. So what is the relationship between the two? Just by looking at this, we just use the molar ratio. The number of moles of sodium thiosulfate is going to be what? The number of moles that we calculated of potassium iodide, and now is when we use the molar ratio and we need the complete and the balanced chemical equation. I look at this part and I see that 6 moles of thiosulfate reacts with 1 mole of iodide. Moles of iodide cancel, and basically all we have to do is multiply this number of moles of potassium iodide by 6. This number 6 is this number 6, and this number 1, this is a 1, is this number 1. So we use the molar ratio, and why is the moles of iodide in the denominator? Because those are the ones that I want to cancel. I am looking for the number of moles of thiosulfate. So my answer will be, in this case, when I do the calculations, I obtain 0.0015 moles of thiosulfate. Very good. This is a good practice. Let's go and look at the next one. What is the concentration? What is concentration? Number of moles divided by volume of the sample. So they are asking for the molarity. What is going to be the number of moles of sodium thiosulfate divided by the volume in liters. So now, what is the volume in liter? Let's read again. The end point was observed to occur at 16.50 milliliters. So we are going to write this volume in liters, which is 0.000 0.1650 liters. And what is the number of moles? What we just calculated, 0.0015 moles. So the molarity that I found is, when you do the calculation, 0.091 molar. Very good. And the last question is, what type of reaction? Obviously, this is a redox reaction. Why is a redox reaction? If we look at the iodate, let's look again at this reaction. The iodate converted into iodide. The iodate convert into iodide. This is a redox reaction. If we balance the equation, 6 electrons plus 6 protons plus iodide produces this. So obviously, this is a reduction, and then you have the other parts of the reaction that is an oxidation. This one, thiosulfate, oxidizes. So this is a redox reaction. Very good. How do we know? Let's look at the iodate, another way of looking. What is the oxidation number of iodide in iodate? Obviously, this is 3 times 2, 6 minus 1, it's 5 plus 5 in here. What is the oxidation number here? It's minus 1. So this is a reduction. You can see it if it captures electrons or if the number is reduced from plus 5 to minus 1. So now that we saw some practice and we looked at the general information, we went over the write-up, let's go over the report and see how are we going to do the calculations. So you will see a report like this. First, you see the standardization. They give you the concentration of the iodide, and they give you the volume of the burette, and then they give you the information for the titration of the bleach. So they are basically two different redox titrations or redox reaction. So we start with table 3. The first thing, standardization of sodium thiosulfate solution. If we don't know the exact concentration of our titrant, we won't be able to calculate the amount of bleach. So the first thing is standardization. Very good. The first question here, volume of thiosulfate. You will have a different data, but obviously it says final burette reading and initial burette reading. How are you going to know the volume that you used? Is obviously final minus initial. So it will be 33.18 minus 1.66, and that is going to be 31.52. So that is easy. Final burette reading minus initial. And you will do the same for trial 2. How do we calculate the moles of iodide? How do we calculate that? We just seen an example. How do we calculate the moles? Always. It's going to be volume in liters of the iodate times molarity of the iodate, right? And what are those numbers? When you look at the procedure, what is the volume of the sample? You have to read the procedure as if you are doing it. And when you read that, the volume of iodate that you use is 0.025 liters. And the concentration is given. Concentration 0.0250. 0.0250. So when you multiply that, in my case, I obtained for the trial 1 here, I obtained 0.0000625 moles. So always calculate it by multiplying the volume in liters by the molarity of the solution you are looking for. The next question, moles of thiosulfate. We just did that example. We know that when you look at the molar ratio, what do you know? That the number of moles of thiosulfate is going to be the number of moles of the iodate that we just calculated, and then is when you use the molar ratio of the equation that we just seen in the practice. 6 moles of thiosulfate per 1 mole of iodate. Very good. And the last part is calculating the concentration. We just did that. This is, I'm using the data, my data, that is different than your data, for the trial 1. And what is the concentration? The concentration is always the number of moles of thiosulfate divided by the volume in liters, right? Okay, what is the number of moles? What is this number, what I obtained here? In my case, I obtained 0.00375. And what is the volume? Obviously, is the volume that we use in the end point. So the volume that we use in the titration. That's why we are titrating. We use, I got 31.52, but we need to convert it into liters. So that will be 0.03152. And that is how you calculate the molarity of your titrant. That is the standardization. Then you do the same thing for trial 2 and you average both values. You add them together and divide by 2. Very good. Once you have the concentration, Let's say I got a number that is 0.119 molar. Let me see if I can write it. Is 0.119 molar. Very good. This is the value for the average concentration. Now we are doing the second titration. We are calculating the amount of bleach, the amount of hypochlorite in the bleach sample. So if you remember the procedure, first you weigh the grams, you weigh the beaker with the bleach and then the empty beaker, and by difference you calculate the grams of bleach that you are using in your titration. So obviously it's 47.141 minus 37.131. This is how the mass of the beaker and the bleach minus the mass of the empty beaker. So it's 47.141 minus 37.131. And that equals 10.01 grams. So this is the mass of the bleach that you are going to use for your titration. Then you start your titration, and they are saying initial, you did the titration until the color, the blue dark color disappear. The final volume is this. So how do you calculate the volume of titrant? Again, you just do final minus initial. So it will be 25.76 minus 1.34, and my value is 24.42 mLs. Very good. So this is the volume that I used until the end point in the titration. Then what else I need to calculate? The moles of thiosulfate. How do I calculate that? Always the same way we said that the number of moles is always volume in liters times concentration, molarity. In my case, what numbers are those? What is the volume? It's 24.42, but I have to convert it into liters, 0.02442. Now my volume is in liters. And then I multiply by the molarity. We did that in the previous titration, 0.119 molar in my case. For the trial one, I obtained 0.00291 moles. Very good. So always volume times concentration. And this is the concentration of the titrant that we obtained when we did the standardization in the first part. So now that we have the number of moles, we need to know the number of hypochlorite that was neutralized. If you remember, when you look at the equation, again you use the molar ratio. And you know that the number of moles of hypochlorite this is a Cl, is going to be the number of moles of the thiosulfate that we just calculated multiplied by the molar ratio. When we look at the equation, we know that 1 mole of hypochlorite reacts with 2 moles of thiosulfate. So all we have to do is divide this number by 2. And we obtain the moles that I obtain equals 0.0014455. Now comes, if you don't read the procedure, you will be in trouble. Because here it says moles of hypochlorite neutralized. And here it says moles of hypochlorite in the bleach sample. So why is there they are asking for both? What is the difference between both? When you read the procedure, actually, let's look at the procedure. When we look at the procedure, you will read, let me find it here, where it says, okay, so let me, if I will share this, what happens is that, okay, let me share this anyway. This is going to be erased, but it doesn't matter. Let me share the page of the experiment because you need to be able to read this. Okay, so we went over this, and this is actually the general information. And then comes here the procedure. We did the standardization, and we saw we use these 25 ml of sample. And then comes the determination of the amount of hypochlorite in the bleach. So when you read all this is very important, because otherwise you won't know how to do the calculations. So first it says you weigh the amount. We have that. And we carefully transfer the bleach into 100 ml volumetric flask. That means that all our bleach is contained in 100 ml. But then when we did the titration, we measured 25 ml of this solution, which means a quarter of the whole sample that we weighed. So we, in order to have, if if the values that we obtain is for just 25 mLs and the whole sample is 100 mLs, we need to just multiply by 4. So let's go back then to our report. Okay, so we did the standardization. Now we are doing the sample. So we did the volume. We know how to calculate the moles of thiosulfate, the moles of hypochlorite that we neutralize because we use 25 mLs. And what is the value that we calculated when we did that? We obtained 0.001455 moles. This is the moles of hypochlorite in 25 mLs. But then they say the moles in the bleach sample, the whole amount. So all we have to do is 4 times, because the whole amount of sample is contained in 100 mLs, 0.001455, and my value for trial 1 is 0.00582. So this is the moles of hypochlorite in the 100 ml of the sample, which is the grams that we weighed. And then they're asking, what is the mass? If we have the moles, that's from Chem 1. How do you convert moles into grams? All you have to do is multiply by the molar mass. So you do 0.00582 moles multiplied by the molar mass, which is the molar mass of sodium hypochlorite, which is 74.44 grams per mole. And you obtain a mass that is, I obtained with my data, 0.4332 grams of sodium hypochlorite. Very good. And the last thing they are asking us is the percentage of sodium hypochlorite in the bleach sample. If you have the grams, this is easy peasy, right? What is the percentage? The percentage, every time you calculate a percentage, is what? The grams that you have, in my case, 0.4332 grams times 100 and divided by what? By the grams of bleach sample. In my case, when I started, I weighed, remember with the beaker, was 10.01 gram. So for me, I have a percentage, in my case, of 4.328%. And that number goes here. And then you will have another similar number, and you do the average. You add both and divide by 2, and then you obtain the average. And this will conclude this workshop of this experiment, which is the determination of the amount of sodium hypochlorite in commercial bleach. Thank you everybody for listening, and looking forward to seeing you next week. Thank you.